Hi everyone, today's presentation is on Alopecia Areata. This is an immune-mediated condition where the body's own immune system mistakenly attacks its hair follicles, which leads to hair loss. While some shedding is a normal physiological process for animals, Alopecia Areata is an abnormal condition that results in hair loss that can be either localized in specific areas or spread out across the body. As the slide indicates, Alopecia Areata is an autoimmune disorder. This means the body's immune system attacks the hair follicles. A key characteristic of this condition is that the hair loss is non-scarring and the hair follicles itself is preserved. This is important because it means there is potential for hair to regrow if the immune attack ceases. The hair loss can show up in different ways, from well-defined patches to more diffuse or even total hair loss. To understand Alopecia Areata, we first need to understand the normal hair cycle, which has three main phases. Anagen, growth phase, which is the active phase where the hair follicle is deeply rooted and the hair shaft is actively growing. This phase can last from weeks to years. Catagen, regression phase, which is a short transitional stage where the hair growth stops and the lower part of the follicle begins to shrink. It typically lasts for a few days to weeks. Telogen, resting phase. In this phase, the hair is no longer growing but stays in the follicle until it's eventually shed. A new hair then begins the anagen phase again. As the diagram indicates, Alopecia Areata disrupts this cycle. It's an autoimmune disease where the immune system specifically attacks the hair follicles during their active growth phase. This attack forces an early shift into the catagen and telogen phases, leading to hair loss. Historically, several causes for Alopecia Areata were proposed. This included infection, thallium acetate poisoning due to similar clinical look, trophoneurtic hypothesis, which linked the onset of the condition to emotional or physical stress and trauma, thyroid disease and hormonal fluctuations, such as those that occurred during pregnancy. While inflammation of the hair follicles was described over a century ago, the immune system was only recognized as the primary cause in the late 1950s. Today, we understand it as an immune-mediated condition. The mechanism of Alopecia Areata is complex and involves both genetic and the immune system. 1. Autoimmune attack targets anagen hair follicles. The core of the disease is that the immune system attacking hair follicles while they are in the active growth phase. 2. CD8 plus NKG2D plus T cells drive inflammation. The primary drivers of this attack are a specific type of cytotoxic T cells, known as CD8 plus NKG2D plus T cells. Their survival and function are dependent on cytokines like IL-15. Gene expression studies show that the interferon gamma pathway is also involved. 3. JAK-STAT pathway or JAK-STAT pathway is central in the disease signaling. This inflammatory cytokine signal through a pathway known as JAK-STAT pathway. Because this pathway is central to the process, it has become a key target for new therapies, specifically using medication called JAK inhibitors for HLA-DRB1 and 40 other loci linked through GWAS. Large-scale genetic studies have confirmed a strong genetic link. The HLA region, which is crucial for immune regulation, was identified early on as a major contributor, specifically the HLA-DRB1 region. In total, about 14 different genetic locations have been associated with Alopecia Areata. 5. Unique genes like KLRK1 and ULBP3 involved only in Alopecia Areata. Interestingly, some genes have been implicated almost uniquely in Alopecia Areata and not in other autoimmune diseases. This includes the genes like KLRK1 and ULBP3. This finding suggests these genes play a key role in the specific pathogenesis of this disease. 6. CRISP1 gene linked to the hair fragility in mouse models. Beyond the autoimmune attack, research in mouse model suggests that the hair shaft fragility could also play a role. The gene CRISP1 was identified as a potential contributor to hair shaft weaknesses, which could predispose the hair to breaking or filling out. This suggests a more complex picture where genetic factors are involved in both initiating the autoimmune response and in the structural integrity of the hair shaft itself. Thank you.